What is the specific heat capacity? The definition is the total amount of heat required to increase the temperature of a unit mass of a material 1 kilogram of a substance by 1 Kelvin. The total amount of heat added into a body of a mass to change the temperature. Specific heat capacity affected by three factors, which is the mass of the object, the type of the object, and the last one is the amount of heat supplied. A formula we'll use in this chapter. It is Q equal to mc theta. In the same time, it is C equal to Q over mass delta T. Q defined as heat capacity in joules. M defined as mass in kilogram. Then C defined as specific heat of the object. And the last one is theta defined as the temperature change in Kelvin or degrees Celsius. Unit SI for specific heat capacity is joules per Kelvin or joules per degree Celsius. We know that specific heat capacity was applied in our life. What is the example of application of specific heat capacity? We have three examples, which is the cooking pot, cooling system, and the last one is sea and land breeze. Firstly, cooking pot. On the cooking pot, we had a body, base, and handle, which are made of the materials with different specific heat capacity. The base of cooking pot was made of metal, a material of low or small specific heat capacity, which is to enable rapid heating. It becomes hot very quickly, so it enables quick cooking of the food in the pot. Besides, it is high density because the heavier base ensures that the pot is stable and will not topple over easily. Second, the handle is made of plastic or synthetic material. It had high specific heat capacity, so it doesn't mean that the heat transfer from the pot to the handle is low. Therefore, it will not become too hot when heat is absorbed. Besides, it is poor conductor of heat. Just little heat from the body of the pot is transferred to the hand of the person holding the pot. Lastly, handle is low density. It does not using heavy material, so the pot is lightweight and friendly to use. Usually, the body made of aluminium. It is had low specific heat capacity, so aluminium body becomes too hot quickly. Besides, it is low density and it does not react with the food on the pot. In addition, we know that clay pot was used at the restaurant. Why it is? So here, the I can clarify is clay pot has a higher specific heat capacity than metals. It is also a poor conductor of heat. During cooking, heat is conducted slowly from the fire to the food inside the pot. A longer cooking time brings out the taste in the food. After the flame is switched off, the clay pot is at a higher temperature than the food inside it. A considerable amount of heat continues to boil for a few minutes after the clay pot has been removed from the fire. Second application is cooling system. We know that water is used in the car radiator as a cooling agent. It is because water had high specific heat capacity. It can absorb a large amount of heat which later increase in temperature. Besides, water is readily available at low cost. Therefore, water very useful as a cooling agent in car engines and large machines that generate a lot of heat. For the land breeze, During nighttime, land breeze is natural breeze that blows from the land toward the sea. Both sea and land lost heat. However, sea cools down slowly as water or sea has a higher specific heat capacity than land. This causes cool air to move towards sea. Whenever sea breeze during daytime, sea breeze is natural breeze that blow from the sea towards land. Both sea and land absorb heat. However, land is heated to a higher temperature as water or sea has a higher specific heat capacity than land. This causes cool air to move towards land. So that's all for specific heat capacity. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is LIYANA binti AKHBAR and I'm from AS1202F. Today I'll be presenting about the latent heat. So what is the definition for latent heat? So latent heat is the heat energy that is required for a material to undergo a change phase without changing the temperature. There are four main changes of phase, which are melting, boiling, condensation, and solidification, or we call it as freezing. When a solid is changing their phase to liquid, the latent heat is being absorbed, and when liquid changing their phase to gas, the latent heat is also being absorbed. But when the gas is changing its phase to liquid, the latent heat is being released, and same goes to liquid changing its phase to solid. The latent heat will also be released. This is a summary of processes and the latent heat involved. Firstly, when the process is melting, the change of phase is solid to liquid and it occurs at melting point. The latent heat is being absorbed. Secondly, the process is boiling. The change of phase is from liquid to gas. It occurs at boiling point and the latent heat is also being absorbed. Thirdly, the process is condensation. The change of phase is gas to liquid. It occurs at boiling point and the latent heat is released. And the last one is when the process is freezing, the change of phase is from liquid to solid and it occurs at melting point or boiling point. The latent heat is also being released. So this is the heating curve for a substance in a solid state when it is heated uniformly and undergoes a change of phase from solid to liquid and to gas. So firstly, at point PQ, the solid is heated to its melting point. At point QR, the solid is melting. At point RS, the liquid is heated to its boiling point. And at point ST, the liquid is boiling. And the last point, TU, the gas is heated. And all the heat energy at all points is being absorbed. So this is the cooling curve for a substance that changes its phase from gas to liquid and to solid. The first one, at point PQ, the gas cools to its boiling point. And at point QR, the gas condenses. At point RS, the liquid cools to its freezing point. At point ST, the liquid solidifies. And the last point, at point TU, the solid cools down. And the heat energy for all the points is being released. Next, we move to latent heat of fusion. So what is the meaning of latent heat of fusion actually? So the definition of latent heat of fusion is the amount of energy that must be supplied to a solid substance in order to trigger a change in its physical state and convert it into a liquid at a constant pressure. So the particle in a solid vibrate about their fixed mean position. During melting, the latent heat is being absorbed, and then the heat being absorbed is used to weaken the bond between the particles. The particles are now free from their fixed position and are able to vibrate and move among each other as the particles of a liquid. The heat absorbed by a melting solid is known as the latent heat of fusion. Next, I will move to latent heat of vaporization. So what does latent heat of vaporization means? So latent heat of vaporization is a physical property of a substance. When a material in liquid state is given energy, it changes its phase from liquid to vapor without change in temperature. The particles in the gas are in continuous random motion, which means they are much further apart from the particle in a liquid state. When a liquid boils, the latent heat is being absorbed, and the heat that being absorbed is used to, firstly, to completely break the bonds between the particles, and the second one is to do work against atmospheric pressure when the gaseous vapor expands into the atmosphere. Then, the heat absorbed during boiling is known as the latent heat of vaporization. Next is the application of latent heat. This is some of the application of latent heat. Firstly, we always want our drinks to be cold, right? So the alternative is to put our drinks in a bowl full of ice. So after several minutes, when we take out our drinks, it is really cold and it's even colder. So why do this happen? Well, this is because when ice melts, a large amount of heat is absorbed and this lowers the temperature of the drink. Thus, our drinks become colder. So the next application is, we usually saw people who sell the fish or meat at the supermarket. They usually put lots of ice at the fish and at the meat. So why do they do that? So this is because the freshness of fish and meat can be maintained by placing them in contact with ice. With its larger latent heat, ice is able to absorb a large quantity of heat from the fish as it melts. Thus, food can be kept at a low temperature for an extended period of time. So the last one is, I usually saw my mother make steamed fish. So I keep thinking, can the fish really cook well? So this is the answer. Water has a large specific latent heat of vaporization. This property enables steam to be used for cooking by the method of steaming. When steam condenses on the food, the latent heat is released directly onto the food, enables the food to be cooked at a faster rate. So I prepared some question and answer for this topic. So the question, an ice cube in the freezer compartment is dry, but it quickly becomes wet after it is taken out of the refrigerator. Why is that so? So the answer, in the freezer, the temperature is below the melting point of the ice cube. It remains in the solid form. Outside the refrigerator, the ice cube is colder than the surrounding. It absorbs heat and melts. So the next question that I have prepared is it possible for a solid to change directly to a gas? So the answer is, it is possible. This process occurs for a certain solid such as iodine and solid carbon dioxide, which is also known as dry ice. This process is known as sublimation and requires the absorption of latent heat. So the process name is sublimation, which changed the phase from solid to vapor. This is our list of references.